some conversions. However, in lesson 14, we're going to not be working with such easy numbers. We're going to be working with fractions and decimal fractions. I will pass out conversion tables to you guys tomorrow in class. Tomorrow's Tuesday, so you do not need to commit all of these conversions to memory. What you do need to begin to commit to memory though, is this algorithm. We're going to continue using the same algorithm. We're going to go through it quickly, so you need to pause when you think about when you need to pause, or rewind if I'm going too quickly. And this algorithm we practice a lot today during class really should start making sense. And if you are just completely in the dark, please go back and watch lesson 13 video where we began to use this algorithm. So we're in problem set. We're going to do some conversions. The first one's done for us. Still, the first set of parentheses and our second set of parentheses and our first and our second line are equal to one another. But now you guys can see we're actually using fractions. 1 day equals 1/7 of a week. So what we're actually going to be doing is multiplying with fractions and decimals. Let's go ahead. We're going to look at C and E right now. And we're using metric conversions here. See, we're converting centimeters to meters. You guys should be very comfortable with the fact that we will find 100 centimeters in 1 meter. Okay, so let's look at this one here. First line, again, we're just unpacking what we're starting with. 920 centimeters. Let's unpack that. 920 centimeters is equal to 920 copies of 1 centimeter. Here we are in the first line. We talked about this today in class in small group. 920 copies of 1 centimeter. When we get into the second row, this is actually when our conversion comes in. I'm making that sideways equal sign. Tilt your head to the left or the right and you'll see this is an equal sign. Let's go to our second row here. We're looking for 920 copies of something in meters that is equal to 1 centimeter. 1 centimeter, think about if you're holding 1 centimeter in your hand. If you're holding 1 centimeter in your hand, you're holding 1/100th of a meter in your hand. If you're holding 1 centimeter in your hand, you're holding 1/100th of a centimeter in your hand. If by the time we get down to our third row here, we just need to multiply through. 920 times 1/100th equals 9.2. Another way we can look at this 1/100th, we can look at it in decimal form, or we can look at it in fraction form. 1/100th can be written as a decimal or as a fraction. We have 1/100th in decimal form or 1/100th in fraction form. So the answer for C should be 9.2 meters is equal to 920 centimeters. Okay, let's look at the next one. Let's look at E. Here we're converting grams to kilograms. This kilo refers to 1,000. So let's go ahead. I'll write the conversion up here. We find 1,000. We find 1,000 grams, a lot of grams. 1,000 in fact make up 1 kilogram. Okay? This information I will provide to you guys. You do not need to memorize all this overnight. What I do need you to continue working on, however, is this algorithm. And we're going to set it up the same time every time. Okay. So here we're receiving kind of less scaffolding. Up here we received some information by Eureka, but here we're kind of just doing it on our own. But let's get into it if I can get my pen down here. Okay, so we're starting with 6,080 grams. We need to convert that to kilograms. But as you guys know, on our first line, what we're doing is just unpacking what we have. So we have 6,080 copies of 1 gram. So this is our standard algorithm. Do you guys see how it's the same every single time? 920 copies of centimeters, 1 centimeter. Up here's the same thing. First line, 28 copies of 1 day, 1 day. Yes, okay, so this should this should become a little bit familiar to you guys, and I hope some of you are already predicting what's going to happen on the second line. So again, we're still making 6,080 copies, but this time we're going to set up our conversion. Our first set of parentheses, and again, I don't have enough room, our first set of parentheses needs to be equal to the parentheses that we find on the second line. This is a sideways equal sign, not an 11. You can turn your head to the left or the right and you'll see what I mean. We have to think about in fraction form. If we're holding 1 gram in our hand, how many kilograms are we holding? So let's go back up here. I gave you the information. I let you guys know, a lot of you guys already know this though, that 1,000 grams equals 1 kilogram. So clearly, if we're only holding 1 gram, we're not holding an entire kilogram, we're holding a fraction of it. We're actually holding 1,000th of a kilogram, right? 1,000th of a kilogram. Now we need to multiply for our third line. We're going to multiply 6,080 times 1, and we're going to get, I know we haven't really looked at multiplying fractions yet, but just hang in there. 6,080, I think I might have said that. I might have misspoken. 6,080 times 1 is 6,080, and then on the bottom we're multiplying, there's nothing on the bottom, so we're multiplying 6,080 over 1 times 1,000. We're going to end up with 6,080 over 1,000. Let's simplify that. Another way we can say this is 6,080 divided by 1,000. You guys know when we divide a number, where it's going to get smaller, we're going to move it to the right on the place value chart. We're actually going to move it 3 digits to the right, 6,080 that is, and we're going to end up with 6.08 kilograms. 6,080 grams is equal to 6.08 kilograms. There we go. We are still doing our conversions. This is starting to look a little bit more word problem-y. So let's just look at the information that we're given. I see meters and kilometers already. Let's establish the fact that there are, do you guys see that kilo? Yes, I think a few of you are thinking kilo. Okay, that means 1,000 because there are 1,000 meters in 1 kilometer. And again, this is not information that you need to commit to your memory tonight. I will provide you with this information. What I need you to commit to your memory is this standard algorithm. So let's take a look at this. First line, we're going to unpack what we are given. Let's actually read this first. The distance was 264,040 meters. Convert this distance to kilometers. Okay, so let's unpack what we're given. This is always how we're going to start our conversions. So 264,040 meters is equal to 264,040 copies. Oh, I think I'm running off. Copies of 1, can I write on here? Sweet, meter. Okay. We're just unpacking what we're given. Now we're going to get into the conversion. So equals, we're going to repeat the amount of copies that we have, 264,040 copies of, now whatever is going in the parentheses on the second line must be equal to this. So 1 meter is equal to how many, we're converting to kilometers, is equal to how many kilometers? There are 1,000 meters that live inside 1 kilometer. So if you are looking at 1 meter, that is not a full kilometer. That is a fraction of a kilometer. In fact, it is 1,000th of a kilometer. It takes 1,000 meters to make up 1 kilometer. Okay, so now we're actually going to do that multiplication. We're going to multiply 264,040 times 1,000. So we'll multiply this number times 1, and we will get 264,040. And the denominator for 264,040 is 1. Anything times 1 is that number. So we have 264, sorry, this is kind of hard to see. 264, I'm having a difficult time saying this, and I'm really not sure why. 264,040 over 1,000, or 264,040 divided by 1,000. Let's write that. Oh, these mean the same thing. When we divide 264,040 by 1,000, this number is going to grow smaller. We're going to shift these digits to the right 1, 2, 3 place values, and we're going to end up at 264 and 4 hundredths kilometers. Okay, so 264,040 meters is equal to 264 and 4 hundredths of a kilometer. Did that go too fast? Think about your thinking. Do you need to rewind and look over this again? I will tell you right now, the secret word is chocolate chip ice cream. You are going to be sharing that secret word with me in the morning. Otherwise, I look forward to seeing you guys tomorrow for another great day in Mathland.